Okay, so the lesson for today is what is a triangle geometry, semester 1. This is study 2-1. Okay, so in 15 words or fewer, write your own definition of a triangle. A triangle is just a polygon with 3 sides. The sum of the angles equal 180. So let me write that down. Okay, so I just went ahead and wrote that down for you. It's a polygon with 3 sides. The sum of the angles equal 180. Now it says to draw for practice 2. Draw three triangles in the space below. So here I go. One I would consider to be kind of equilateral where all the sides are the same. I'll go ahead and draw a right triangle where you got a 90-degree angle. Whoops, gotta close them up. Or maybe even a scalene one or two. Okay? Don't let those definitions or those way that I described those 3 bother you, because we're going to go into greater detail in a minute. So practice 3 says label the triangle parts with side, vertex, or angle in each blank. Then define each part labeled below. So we'll do this part down here. But for right now, let's label it. Okay, so we got our 3 parts labeled. The vertex is just going to be the point there at the top, which you see here. And if you have more than one, which in this case a triangle has 3, we call them vertices. Your side is labeled in blue right here, and the angle is in red, located right there, and the triangle has 3 angles. So by triangle parts, the 3 sides are going to be line segments that connect the vertices. So I'll write that down. Okay, the 3 vertices are going to be the points where the 2 sides meet. Okay, the 3 angles are a pair of intersecting either sides or segments will fit there. Okay, and that's what it looks like all filled out. Practice 4 says fill in the blanks to describe how the parts of this triangle are related. Okay, and on this one, we're going to start identifying the sides that's opposite of angles, because this plays a big part in geometry. So what you can do, and I used to tell my students to physically put their finger on what it was they were trying to identify. So if I say I'm trying to figure out the side that's opposite of angle A, if you cover this angle up with your finger, the only side that is not touching BC will be considered the side that's opposite of it. So on this line right here, we would put, we would put BC, that segment. Okay, if you cover up angle B, which is here, then the side that's opposite is going to be AC. And if you cover with your finger, you can see it. And so if we cover up angle C, which is here, C is there, then my side that's opposite is going to be AB. Now in this part, we want to talk about the included angles between 2 sides. So I'm going to do this one in black. If you have the side that is AB and the side that is AC, then the angle that's included in the middle is going to be that angle A. So in other words, it's the angle that's adjacent to those sides. Just the opposite of what we did. If you look, the angle that's included between AB and BC, well, they actually happen to share the side, the angle B. So B would be the angle that's in the middle, and then the same thing, the angle included for AC and BC, they both share C, so that's going to be your angle. Let's write it down. Okay, so then 5 says using visual cues and summarizing. List all possible ways to name the triangle at right. Now we have 3 letters, D, E, F. So there's 6 ways to do that. 3 times 2 times 1 is 6. So therefore we have 6 ways. And you'll learn more about that in math models probably. That's called factorials. So remember, when you have a triangle, I'm going to do my best to write it. But let's say you have a triangle, and a triangle symbol is just a triangle. So we say triangle EDF, EDF. Then we can also call it triangle DFE, or we can call it triangle FED. And I try to keep it in order. And then another way you can name it is just going backwards. So I'll write those down really quickly. That's all the ways you can name this triangle here to the right side. Okay, so practice 6 says activate prior knowledge and organize information. We want to write the correct number in each blank to complete the review list. So just in practice, some things you learned from Unit 1, they are triangle facts. Triangles are closed, two-dimensional figures. Whoops, let me do that in black so you can see it better. They are formed by three segments that connect three non-collinear points. And remember, non-collinear just means not on the same line. They have exactly three sides and three angles and three vertices. Vertices being the plural of vertex. Each side is included between two angles and is opposite one angle, and each angle is included between two sides and is opposite one side. Okay, so this part right here says give one reason why each figure below is not a triangle. So the first reason why this one is not a triangle is that it's not three sides. Another reason is that it's not a closed figure. Closed figure. I'll type from now on because that looks messy. All right, so right in here, by that not being closed, not a triangle. The circle is not a triangle because it has no sides and no vertices. Okay, and a square is not a triangle because it doesn't have three sides. Okay, so we got all of that written down. Let's move on. Okay, this part is very important because it comes up on your quiz a lot. Practice 8, it says complete the chart, write acute, obtuse, or right in each blank. Sorting triangles by angle measures. So when we look at the angle measures, we have an acute triangle first. And it's important because an acute triangle has all angles that are less than 90 degrees. Kind of like an acute angle. All the angles are going to be less than 90 degrees as well. Our next type of triangle is going to be a special one. It's a right triangle, and a right triangle has a lot of rules. And a right triangle is special because it has only one angle that is 90 degrees. Something important, a right triangle, we normally put a box in the corner. You may not always see 90 degrees, but also a right triangle, one triangle cannot have one angle, two 90-degree angles. So I'm going to write that down as a little note for yourself. Let me type it. Sorry, it looks a little messy, but one triangle cannot have more than one right angle. It's just not possible. And our last type of triangle is an obtuse triangle. And an obtuse triangle is important because it has only one obtuse angle, that angle being greater than 90 degrees. Just like the right triangle, the obtuse triangle, in a triangle can only have one obtuse triangle. If it's more than one obtuse triangle, then it's going to be more than 180. So I'm going to write that down as a little note. And that's how we know. You can only have one obtuse angle in a triangle. All right, anything else will be greater than 180. And that won't make no sense. All right, let's keep going. Okay, when we sort triangles by the side lengths, there's three names for it. You got your equilateral, isosceles, and scalene. And they actually go in that order. So I'm going to write one down. Hold on. So your equilateral triangle is called equilateral because that word equal that's inside of it. All three sides are going to be equal. And you may, instead of seeing the lines for the side lengths, you may just see tick marks. And it could be one on each one, or it could be two on each one. But either way, that means all them sides are the same length. All right, you got your isosceles triangle, and it's called isosceles because it has two congruent sides. When you think about isosceles, think about you got two eyes. So it could be 3 and 3, or it could be 2 tick marks and 2 tick marks, or it could be 3 tick marks and 3 tick marks. However they decide to do it, that means that those two sides are congruent. Okay, and then our last one is going to be scalene. Scalene triangles, they have 0 congruent sides. Okay, just like here you got 3, 5, and 7. So let me do a little bit extra because this gonna come up when you do your quiz. Okay, what's important for you to know is that an equilateral triangle is also considered acute, and the reason being is because all the angles have to be 60 degrees. So I'm going back over here to this one to start. All of those angles are going to be 60 degrees if it's equilateral. It got to be equal angular, making it also acute. All the angles are going to be less than 90 degrees. In our isosceles triangle, for example, this one right here, and I'm just going to assign some number values. Hold on one second. Now, the numbers wouldn't fit, but let's just say this one, this isosceles triangle right here is going to be a 110-degree angle, a 35 and a 35. That would also make that triangle obtuse. If I was what? I just spelled that wrong. Hold on. I pressed the wrong button. There we go. What's going on? Okay, I don't know. Let me fix it. Gotta do the whole thing over. Okay, so that would make this one right here obtuse. obtuse. All right, in a scalene triangle, I don't even want to make up numbers for that, but that scalene triangle could also be obtuse, or it also could be acute. It just depends. Okay, now when we sort the triangle by the side lengths, this is just a visual for you if you'd like to have one. Pretty much all triangles that are equilateral, they would also be isosceles at the very least. So hold on, let me write these things down. Here's what I was saying. All triangles got to be that are isosceles got to be equilateral at the very limit, because don't forget, equilateral, you got 3 equal sides, and isosceles you got 2 equal sides. I don't know why I just did a pi symbol. All right, 2. One more. Sorry, getting better. And then you have on the opposite side of that spectrum, you got scalene, where they don't have not one side that's equal. So let me write that down. And that's your picture of your completed portrait there. Okay. So practice 10 says fill in the blanks to complete the theorem and its word equation. So triangle inequality theorem, the sum of the lengths of any 2 sides of a triangle has to be greater than the length of the third side. So I'm going to write that down. That's everything going on written down. And then I was pleased to see this, because this is actually a shortcut right here, that what I'm about to read to you, which is practice 11. It says making mental images, fill in the blanks to complete the steps. How to apply the triangle inequality theorem. You're going to be given 3 possible side lengths. You need to identify the greatest side length, or the longest one. Okay, you're going to find the sum of the other 2 lengths. Next thing you're going to do is compare the results from step 2 and 3. If the sum is greater than the greatest length, the length can form a triangle. Okay, so there we go. The lengths can form a triangle. 12 says use the steps above to decide if each set of side lengths can form a triangle. So you're going to write triangle or not a triangle, and we're going to show our work. Okay, so here we go. The first one that we have here is going to be sides 3, length 3, and 3. And that got to make a triangle. And on this one, I'm going to put something a little bit special besides just the word triangle. It's actually going to be an equilateral triangle, because all the sides are the same. Okay, and then you got 3, 3, 9. So if I follow the steps here, my greatest side is going to be 9. So I need to figure out if 3 plus 3 is greater than 9. 3 plus 3 is 6. 6 happens to not be greater than 9. So just because that didn't work, it's going to be a no. Okay, and then 7, 6, 9. 9 is going to be my greatest side. So I need to see if 7 plus 6 is greater than 9. And 7 and 6 together is 13. Therefore, this one is a yes. We would have a triangle on that one. Okay? I'm going to encourage you to do the check-up practice problems. Remember that I am always here to help you. Check it out. Look at it. If you have any questions, I am here to help you.